Hi everybody. Welcome to week 10, lecture 1. It's our last in-person lecture for the term. So yeah, have you felt like the, I thought there's an alarm going off. Have you felt like the term's gone quickly or slowly? A few mixed answers. And I'll just turn myself down a bit actually. Oh, here we go. Okay, all right. Do you want to call them again? Hello?
No, there's no one there.
Yeah, that's all right. Sorry guys, this phone.
Can we answer that?
It didn't answer. All right, let's get started.
Oh,
we can't.
yeah, exactly. But I don't.
And we definitely can't. Sorry guys. Oh. There's nothing we can do to disconnect anything.
What? Yeah, it just hangs up when you answer. It's wedged in.
Does anyone have small hands?
I don't know. I don't think there's anything I can do.
Could you just maybe run outside or get Rosemary to run outside and call them again?
Yeah.
Yeah. Yeah. All right. Sorry? I can't hear you. Just call on your phone, yeah. Okay, so let's try and get started. I'm sorry about the phone. We are trying to fix it. Shh, shh, shh. While it's not ringing. Shh, shh, shh. Okay. So as always, there should be links to the live lecture code. If you haven't done your My Experience survey, please do it. Please feel free to reference this phone in your My Experience survey. But yeah, it's anonymous. It's in no way linked to your marks for the course. Somebody's asked me that. It's just to give feedback. All right, I think 37% of the course has done it, which actually isn't that bad, but you know, it could be a lot better. All right, there are some revision sessions on next week. So keep a lookout on the forum for announcements and to sign up for that. There are the week 10 practice exams on this week. So if you go in person, you'll have another chance to go into the exam account or environment and see what it's like. So if you're the sort of person that, I don't know, struggles with font sizes or color schemes while you're coding, it's a really good opportunity to go in and play around with the settings. Ask the tutor for help if you want to play around or adjust the settings, because there are different things available. So it's a good chance to get that working for you before the actual exam. And if you've got any major concerns about something like that, let us know as well. But you might, there's easy fixes in there to change things slightly if you need them. So if you are in an online tutor lab, you can get tickets to go to an in-person one, etc. You can also do the whole practice exam online. So it's up to you what's sort of more important for you. But I do recommend at least logging in and trying a linked list hurdle question in the exam environment, even if you use the rest of the lab to like work on your assignment. How's everyone going with the assignment? Okay. Do you all have other assignments as well? Yeah. I don't have my glasses on. I just realised I can't see very well. That's all right. I can see here, just not out here properly. So there's also an exam environment walkthrough. Just if anybody wants more of a look at the exam environment, you can watch this video. Now, if you go into the exam environment, and you probably noticed this from the week 8 lab test that we did, if you're in the exam account, you won't have access to any of your submissions or code, you know, back on the submissions page. So just be aware of that. But anyway, you can go and do all the practice exam questions online as well. All right, thanks Liam. Hopefully the phone's, it hasn't rung. All right, hands up who's already registered their preference for the exam. Oh, good, very good. Is it still open? It's shut on Wednesday, but it can shut early. Just say everyone's picking the same morning or afternoon session. If you haven't picked it, get in as soon as possible to maximise the chance that you'll get the time slot you're interested in. If you've got another exam on the same day or something like that, the exams team will organise it to make sure you don't have a clash, right? So they're in charge of all of that stuff. But if you've got any concerns, also feel free to email the course account and we'll try and help you work it out. But they should be dealing with that, the exams team. And you'll get an email next week, about mid next week, telling you your exact time and location and all those sorts of details. All right, any question about any of that sort of stuff? All right. So last week we did that email management system thing. It was a linked list application. There was one question we didn't do, and I definitely recommend, I think it was like split emails up. You're splitting up the folders or something. That you had one folder and you're splitting it into multiple folders. So we did the one where we merged multiple folders together, but there's one to take one folder and merge it, split it, goodness. So I definitely recommend trying that particular one. That would be sort of on the harder side of a linked list problem, right? Harder than what you'd probably get in a hurdle. So that's good study for the latter half of the exam. All right, so today we're going to do some linked list hurdles and array hurdles. Hands up who would rather do linked lists. Hands up who'd rather do arrays. People want arrays. All right, we can start with the array ones, and we've got 1 dot and 2 dots. We'll try 1 dots first. In the second half, we've got a special guest lecturer, Tom Kuntz. He's from Optiver, but he used to be a CEC student. He was a COMP1511 tutor and admin for years. So he has a lot of experience with this course. He's going to give some words of wisdom, but also do sort of an array revision problem. And it's one that's related to like a real world situation that, you know, he's encountered in the workplace. So it's going to be like an interesting, but also, you know, revision type of thing. So that's going to be good and interesting. So that's the second half. So let's get started. All right. So this is the first array hurdle example that we'll look at. There's a couple. So often with these hurdles, you'll have an array. It could be an array of ints or doubles, or it could be an array of structs for the first hurdle. For the second hurdle, like the harder array hurdle, the 2.1, you know, it could be a 2-dimensional array. But for the first question, it's going to be a 1-dimensional array, but it could be an array of structs. All right, so this one here is just an array of integers. So in a normal exam, you're going to have a whole spec and lots of example input and output. Here today, you know, it's just me telling you, I haven't written up the whole question. But this one, I hope, is a pretty straightforward one. We've just basically got an array of a particular size that we're told. Right? This is a size 5 array, this is our array, and we're just told to count how many multiples of 3 there are in the array. Hey.
The phone just keeps on ringing, is that right?
It does. It hasn't rung, it rang about 5 times in a row at the beginning, and it's all been super glued so you can't get in there.
I'll just unplug it.
Good luck. And they've super glued all the buttons.
Yeah,
See,
this is really weird.
so you can't stop it.
Cut the cord if I have to.
We wanted to cut the cord, but we didn't think we should. Especially since we're being live streamed.
Oh, really? Okay.
They would, oh yeah, do it.
I didn't say cut the cord.
Okay. So,
Sorry.
shall I keep going?
Yes.
Yeah, I'll keep going. All right, so this is the array, the first array hurdle. Now, hands up who feels like they know how to approach this problem. And
What happens if it stays?
it still rings.
Okay.
It still rings. Who knows how to approach this problem? So what are we going to do? So yeah. Yes, so first of all, we basically do a mod 3 to see if something is divisible by 3 or a multiple of 3. Sometimes when we get to the exam, people forget that mod exists. So sometimes people might use divide or something like that, but we're basically checking if it's divisible. But what else do we have to do? In general words, I guess, we're traversing the whole array. We want to visit every single element in the array once and check if it's divisible by 3. So let's code it up. So to do an array traversal, how would we usually traverse an array? Yes, for loops. We start at index I equals, everybody? 0, yep. And we go till, oh, I'm in the wrong file. Oh my goodness. Trying to multitask. Yeah, make sure you're typing in the right file. Oh, All right. Here we go. So for int I equals 0. I'm going really well today. I is and I++. Okay, so this is just your array traversal. Then what am I doing? Yep, if the array at index I, yep, modulus 3 equals 0, yep. So I'm going to need an integer counter, and I'll initialize that to 0. If I find one that's divisible by 3, which means mod 3 equals 0, I increment the counter. All right. Then at the end, I return it. So this is a possible type of hurdle for the one-dot hurdle. So it's typically going to be some kind of traversal where we start at the beginning and go to the end. Now, in the actual exam, you'll probably use the auto tests, right? But sometimes, get rid of that phone. Sometimes when the auto tests, like if you don't pass one, sometimes it's nice to be able to go through and run your own cases. I don't know if you ever do that, just to see what's going on. Sometimes in the later questions, the auto tests aren't, sufficient, and you might want to run your own test cases then. Just to show you, in a lot of the examples, we've just made a main where we've hard-coded some particular example. Here we've hard-coded this particular array and put in size 5. So if I just compile this and run it, which I've compiled it, it's going to be running this particular example, right? So is this correct? Yeah, we've got 2 multiples of 3. So if you were in the situation where you wanted to construct your own example and think, well, what if it's at the end? I don't know, like in a situation where you're getting bugs or something, you can play around with it. All right. Hands up who feels like they'd be able to get something like this out in the final exam. Okay. And hands up if anybody is like, I don't know, thinks this is an unexpected type of question. It seems like hopefully what you would expect to get, I hope. All right. Let's do the next one though. The next one is a bit trickier because it's an array of structs. All right. And we've been dealing a lot with structs, and we've had pointers to our structs. So we've got to remember when we go back to having arrays of structs where we don't have pointers to them, what do we use to access our fields? Dot instead of arrow. Yep, question?
For the previous question, if we're testing the code out and we're modifying the numbers, will we get penalized if we forget to change them back?
Oh, that's a really good question. If there's a main in our, in situations like this where we're just writing a function, it doesn't matter if we change the main. So when we test it, we'll be testing it with our own mains, so we can test all sorts of different inputs. So this is just here for you to play around with. You can change it as much as you like. We're just going to be testing your function, right? And also with your functions, even if we tell you to write one function, you're allowed to add helper functions if you want. Okay, and you play around with this main, but realize that we're not going to be running that main at all. Your function still has to work. You can't take all the code out and just put it in the main because you don't know how to write functions kind of thing. Anyway, all right. Yeah, so ask questions like that as well. So let's open up the next one. Code array step count. So in this example, we've got a struct, and the struct has the number of steps someone's taken in a particular direction. Why you'd want to measure this in particular, I'm not sure, but Here we go. So each struct is going to have like a number and then a character. Let's make another one. Right, so they're all going to have a number and then a character. We don't even know what these characters could be, but I've put L, R, U for left, right, up, whatever, down. So what we want to do is imagine we're told look for all the step counts for L. We've just got to go through and, okay, this one has an L in it, so we want to add the 3. This one doesn't. This one has an L in it, we want to add the 5. This one doesn't. This one doesn't. We'd want our function to return 8, right? If we said let's look for all the R's, it'd be returning 6. Does that make sense? All right. So again, this is like a whole traversal. We've got to just go through the array from beginning to end. We want to look at every single element in the array. So this part is going to, and we're doing some kind of count. So this kind of part's going to be exactly the same. Right, that part is exactly the same as the last question. Yep. What are we going to do though? How do we do it as we're going along? So we've got our I is equal to 0. We're looking at this. What do we do? Yep.
We check for the direction, and if it's the one that we want, we add the number to a certain sum integer that we create.
Yep. So we're checking the direction, and if it's the one that we're looking for, we increment our counter. That's correct. How do we actually access the direction? Sorry?
Check if it's equal to a character.
Yeah, we're trying to check if, so we've got an array and we've got an index I. How do we access this character in the array? Yep. So first of all, we've got, if I've got any, so we do use a dot, yep, but the first step is to access the whole struct. So if I've got my array, I go to index I. Now if I've just got an array of integers, that's easy, that would give me the whole integer. Here I've got an array of structs, so by saying the array at index I imagine I0, I'm getting this whole struct. Once I have that whole struct, then I've got to access the field I'm interested in. And actually I did that wrong. And the field I'm interested in is called direction. So I'm checking if the direction inside the struct that's in my array is equal to the inputted direction. I'm checking if they're the same. Does that make sense? So when we've got an array of structs, we use the index to get the whole struct. Then we use the dot to go in and get the field. And yeah, I forgot, we're not just incrementing our count. We're going into the struct and getting that number of steps out. So again, we're saying, let's go to the array at index I, and let's go to our number field. So it's probably what you said before, and I just did count plus plus. Are there any questions about that? Is that right? Have I done anything wrong? Yep.
Shouldn't we add array to the counter?
Yep.
Otherwise,
Yep, I should have added that. I just wrote equals instead of plus equals. Anything else that it looks like I've done wrong? All right. So again, I don't have auto test set up for all of these, but let's try and compile it. And this one's called array. Let's try again. Okay, so this compiles. What on earth is going to happen if we run it? Well, again, we've hard-coded some tests that you can play around with. Has anyone seen this kind of syntax before? So don't panic. You're not expected to write code like this, but sometimes we'll set up your tests like this when we've got structs. So you know how you can use the curly brackets when you're hard-coding or initializing numbers in an array? So in the last one, we'd use this to initialize our array, yeah? And you've seen that. Here it's the same thing, except each element is a struct. So when we've done this, we've said dot number equals 3, dot direction equals L. You don't have to know how to write this code, but you could play around with it if you liked, if you wanted to come up with a test case. If you never want to think of this kind of code or look at it again, just stick to the auto tests. So don't panic if you've never seen it. This would just mean we've got 5 structs, 1, 2, 3, 4, 5. The first one has 3 and L, 5 and L, 2, L, 13, D, 30 and L. And it's looking for L's. So it's going to add up 3, 5, 2, and 30. So that should give us 40, right? Let's try. Oh, I think I changed one as I was showing you what they did. So I'll compile it again. There we go, 40. So this is, you know, the type of thing you could expect having an array of structs. Is everyone sort of okay? Don't worry about this test code at the bottom, but is everyone okay with how we work with arrays of structs? Yep.
Sorry, could you remind me, like, for the struct steps part, how is it like an array?
Oh, how is this an array?
Oh, is it because it's declared inside the function?
So this is like an input. So let's just go, let me bring this over here. So in this example right here, we had an array of ints, right? So with an array of ints, when we pass it into a function, you know, we have to give a size, and then we have the type. Then we have the name of the array, which is called ARR in this case. And then we have the brackets. So this is enough to say that we're passing an array into a function, and it's an array of type int, right? When we're doing it like that, we don't have to say how, we don't put the size in these brackets, we don't have to. We're just passing in an array of any size, and then we're saying what the size is here. The type is int, the name is array, ARR. Over here, it's the same thing. The difference is the type is struct steps. So instead of having like int, the type we've got is struct steps. So that makes it an array of structs. Okay. Is that clear? All right. So I think that worked. Now let's do one more. This one is similar in that we've got another array of structs, but this time, you know, there's going to be some different sort of logic involved. So I'll give you all a moment to think about how you do it. But this time we've got an array, and each struct has a first initial and a last initial. But it might not, it might have weird rubbish in there, just things that aren't really initials. B, and trying to do things so you can tell if it's a capital or not. All right, so what we're trying to do is we're trying to check the structs and find the ones that don't have 2 capitals in there. So here we have 2 capitals, capital A, capital F. We don't count that. Here we've got lowercase t, lowercase a. they're not both capitals, we count it. Here we've got exclamation mark 7, they're not both capitals, we count it. Here we've got one capital, one lowercase, we count it. Here we've got capital X, capital Z, we don't count it, right? So everyone know what we're doing? That's the first important step in the exam. Make sure you really understand what you're trying to do. So have a think about how you'd code that up. I'll just give you just a minute or so. Okay, I don't expect you've coded up a whole solution to this, but let's talk about it. Parts of this are exactly the same as the last two examples I've shown you, right? We've got some kind of counter that we initialize to 0. And we're going through our array from beginning to end. And then at the end, we're returning some counter. So I'm not guaranteeing that every hurdle is going to have that, but a lot of them are going to have this basic thing. But then you've got to do something in the middle, right? So at each point, for every sort of item, we're going to the one at index I, and I will be 0, for example, and we'd be looking at this struct. And we have to make sure we look at, well, it's called array, and we're at index I. And then we'd be looking at the first initial. And then at some point, we'd be also looking at that second initial. Oops. But yeah, how do we work out if something's uppercase or not? So there's a few different ways. Yep. The ASCII table. Yeah, we can just check, basically check what range of the ASCII table it's in. Yep.
You could use 2 upper or 2 lower.
Yeah, you can, well, yeah, we can check, we can use the ctype.h library. So unless it says do not use ctype.h, you can use it. And that's nice. Let's try it with that way, and then let's try it without it, just in case, because sometimes on the day, people might forget that it exists or forget how to use it. But that's how I'd do it, unless I was told don't use it. So what you can do is you can just say, if this is telling us whether this is an uppercase letter or not. But then we need a bit of logic here, because we're kind of looking to find out how are we going to use the logic here. Yep. Yeah, we're trying to say, is this not an uppercase letter? Maybe. If the first initial is not an uppercase letter, then we want to count it. If the second initial, oh, it's called last initial. If the second initial is not, if the last initial is not an uppercase letter, we want to count it. So we can do something like, I mean, we've got to put it in an if statement. You can do it like this, or you can say is equal to 0. Yeah. If it's not an uppercase, but how do we join them together? Are we going to use and or? So yeah, we want to use or. So if either one of them is not an uppercase letter, we want to count it. Does that work? Yep.
Could we also do, this case lower, but an and statement?
Someone suggested is lower. That depending on the question maybe, but in this question, if it's not uppercase, it could also be a punctuation mark or a 7 or something like that. So we've really got to check it's not uppercase because it could be anything else. So if either one of them is not uppercase, we're going to count it. Does that look okay? If we put an and, what would that do? If we put an and, that would cover this case because it's like, well, they're both not uppercase. This is an uppercase and this is an uppercase. This is an uppercase and this is an uppercase, but it wouldn't handle this case here because, you know, one of them is uppercase. So this would be saying they both have to not be uppercase. So it's very common that in these questions, you might get a bit of an and or or situation thrown at you, and you might get things about capitals, lower cases, or characters. So sometimes these are the things that make people, I don't know, panic or not do it correctly. Let's try it. And when we print it out, what are we expecting to get if we've got this as the test case? One, 2, 3, right? I'll get rid of that. I wrote is supper. Expected. Oh, I've left off this. Three. Any questions about this? Yep.
Why not just use this lower?
If we use is lower, we wouldn't catch things like exclamation marks. They'd go through, or digits. So in this test case, we've got an exclamation mark. So we have to be careful about that. All right. The other thing is, what if we didn't want to use is upper? What if we forgot about it or never knew about it or whatever? Or we were told we couldn't use it? If something's not uppercase, well, if something is uppercase, you know, it's going to be greater than or equal to A and less than or equal to Z. If it's not uppercase, it's less than A or it's greater than Z. So instead of using not is upper, you could write this, something like this. But does that make sense? So if something's less than A or greater than capital Z or whatever, it's not an uppercase letter. It's something else. Does that make sense? That should do the same thing. Try it your own way. But yeah, I definitely recommend you're on top of doing things like this, ands and ors and characters in these early hurdle questions. All right, there's some array hurdles. Do we want to do, we've got 2 dot linked list hurdles, 2 dot array hurdles, 1 dot linked list hurdles. Hands up for 1 dot linked list. Hands up for 2 dot linked lists. Hands up for 2 dot arrays. I I think it's 2.linked lists. Okay. All right, this is a nice example. So this is like a slightly harder example of linked lists. It's a 2.1. There are simpler linked list hurdles. If we don't have time to do them today, whatever, you can practice them. They're up there. But this one here, and again, if this is a question, would be giving you lots of examples of what's going on. But imagine we've got a linked list, and I think they're of characters here. Which, when it's a linked list, it doesn't really matter what's in it. Okay. So we've got a situation like this, and what we want to do is we want to make a duplicate of every single thing that's in the linked list. So if I've got an A here, I want to create a duplicated node A, but I want to fit it in at this position. Then I've got a D. I want to duplicate that and fit it in here at this position. So by the end of it, you should have a list that is twice as long. Is that right? Yes. With everything that's been duplicated along the way and put in, right? So this is harder than the 1 dot hurdles because we're not just traversing something. We're structurally, if I can speak, structurally changing this list. So that's always a bit harder. But if we think about what we're doing clearly, we're still trying to go through every single node in this list, really. But for every single node in the list, we're trying to duplicate it and connect it up. Okay. All right, so what are our ideas to do this? So we've got the head of our list. I would still make some kind of current thing. Point to here, let's duplicate this node. Now to duplicate a node, we're just going to do a malloc, and then we're going to copy, the value into it. But then we've got to connect it up. So imagine I've called this new node. How do I connect this new node up to the rest of this list? So I've got car. So someone said set current next. So I do need to set current next to point to this node here. But I also need to make sure that this one points to here. So what do I do first and how do I do them? Yeah? Yeah, we've got to do it in the right order. I need to set this first. If I set this first, if I do it the other way around, I'm going to lose the link to the rest of the list. If I change current node, if I say car next equals new node, which I do want to do, but if I did that first, I've now lost this link to this part of the list. So the first thing I do is say new node next. Let me put this back in. New node next equals car next. That's going to put this in here. Then I say car next equals new node. So car next, I'm changing where car is pointing. The next one after car is going to be this new node. So if you can read my writing, and I'll type it in a second, that's how we connect it up. But we want to keep going. Now, often in our traversals, we say car equals car next. Is that a good idea in this case? Yeah, if we move car and say, okay, car equals car next, we're going to set it to here, and then what's going to happen? We'll be creating another A node, and then after we do that, we'll be creating another A node and another A node infinitely. So we don't want to say car equals car next. What do we say? Yep. Yeah, we can say car equals car next. That would work. Not the next one, but the next one after the next one kind of thing. Or we could say, but basically we want it here. So car next or new node next. We want it here, and then we can keep going along and doing the same thing. Eventually car will get to the end and we're done. Right, is everyone sort of happy with that? So and we do return the head of the list. The way we've implemented it, the head of the list is never going to change. But, you know, maybe if you implemented it, you'd be trying to put the duplicate before the original. That would still be correct. I think this is the easier way to do it though. Struct node car equals head. And we're still going until car is null. If we stopped at car next, that would stop us duplicating the last node. So sometimes people stop one early when they don't have to. If you want to do something for every single node, go right up to car is equal to null kind of thing. Okay, now what am I doing? I'm doing So I'm doing my malloc to create my new node. In an exam, we're probably not going to check if the malloc worked. In real life, we do want to. Now we're setting the data inside the new node. What are we setting it to? Yeah, whatever is in the current node, that's the thing we're duplicating. So we set the data inside. And we've worked out that we're going to slot it in and say, oh, new node next equals car next. That's doing this link here. Then we're also saying car next equals new node, because that's putting this link in. And then we're moving car along. To car next. So car next would give us the thing we've just duplicated. We don't want to infinitely duplicate it. We want to go to the next one, which is this new value we haven't seen before. We want to duplicate that. So I think this is it. Now, this isn't a lot of code. It's not that many lines of code, but it's tricky code, you know, to get exactly right. So it is worth that time thinking about it before you're launching in, because it's not going to be 10,000 lines of code in these hurdles. But, you know, having said that, who knows if this is right? Let's see. Oh, this is called, I should save it. And in exams too, like, it's very easy to, when you're trying to hurry, forget to save things or compile them or whatever. Okay, now, often where we've got these linked list questions, if we're trying to run them ourselves, now we don't have to go and look at all this code, but often we can put them on the command line. So I could put in A, Z, C, D, D. It did nothing. All right, so what have I done wrong? What have I done? Oh, I've got this. Did everyone see what I had? I did not even notice that. Thank you. See, this is what happens when you're in exams, right? Or when you're live streaming. Yay. So look, thank you. You deserve 1,000 chocolates. Because I was looking at the rest of the code thinking, what's wrong with it? All right, cool. And that's just also a reminder of what can go wrong. So don't just panic and think, I've done the whole question wrong. I don't know what I'm doing. It's all wrong, and start deleting it all. Have a bit of a look first. Okay, any questions? I think we've got time for one more. I might just do we want an easy linked list one to make us feel good, or do we want a harder array one? Okay, let's do an array one. Let's do a 2D array one. Okay, how do we feel about 2D arrays? Okay, so write a program that finds the sum of the minimum numbers in each row in a 2D array. That sentence kind of hurts my head. But basically for each row, we're finding the minimum value. And then when we find the minimum value in that row, we're adding it to our total sum. Okay, so the main thing is we're finding the minimum in each row. Okay. All right, so in this case, we've got a square size array, so we've only got one size, right? That's not always going to be the case with a 2D array. You might have two inputs for the number of rows, number of columns. They might be different. Okay, but in this kind of situation, if we're just thinking we've got to go through every single item in this 2D array, and we're basically wanting to do each row at a time, what's our for loop or whatever going to look like? So just our basic traversal of the 2D array is going to look like what? Everybody?
We go through the row first. Once we're done, and then move on to the column.
Well, yeah, we're going to go row by row, then column by column. So the row loop will be the outer one, that's correct. So we'll do something like int. Do we like I and j or row and column? Let's do row. And this time, we've only got one size. Oh, I keep writing I. And then, now you don't have to write comments in the exam, but I'm just writing it so we can see what we're doing. Find the minimum of this row. So to find the minimum of the row, we've got to go through every column. And we're going to make sure we sort of initialize, we're going to have some variable that keeps track of the minimum. We want to kind of initialize it in here somehow. And we've got some total. So we keep finding the minimum of each row and then we add it onto the total. And that's what we're returning at the end. So down here, we're going to add the minimum of that row to the total. I'll just say minimum. And then at the end, we return this total sum. So that's the structure of what we're trying to do. the details are, how do we find this minimum? What do we initialize our minimum to? How are we finding this minimum? So what ideas do we have? So for a particular row, I'll just draw some stuff. Okay, so if we're up to row 0, we need to set our minimum to something, and we're going to go in this loop through every single column and check. What are we checking? Yep.
Restore the first value, and if the first value is, the next value is larger than the first value, lower than the first value updated.
Yeah, so we can that's correct. We can initialize this to just the first value in the array. Yep. Or not in the array, in that row. So we don't want to make some artificial value and stick it in like 0 or -1 or at 10,000 or I don't know. We want to use real data. So we're going to say, let's go to the array at this particular row. So yeah, that's another matter. How do we do it in the code? This particular row, but column 0. So in this case, we'd be initializing our min to be 3. And I've left out this part here. Now, when we go through every column in our row, if we start at column 0, we're unnecessarily comparing our 3 to 3, but it doesn't really matter. We're comparing this to this, and we're saying, well, if the one at array at index row col is less than the minimum, I'm going to update my minimum to this value. So this is a standard way of finding the maximum or the minimum. Okay, and in this case, no, it's 3 and 3. I moves along, we then compare 1 and 3. We would update this value to 1. We'd compare the 7. We'd compare the 4. And we'd end up with the minimum for this row is 1, and we'd add it onto our sum. And we'd do that again and again. We'd end up with 1 plus 3 plus 0 or something like that. Does this look right? Now, if we wanted to be really fancy, we could say, well, I've already used the one at index 0 here. I could start this loop at index 1. But honestly, in an exam, you don't have to worry about that. In this course, you wouldn't have to worry about it either. You're going to get the right answer. So don't overcomplicate it with those sorts of thoughts. Okay, let's try it. Down the bottom, again, we've got hard-coded test code. Oh, I don't know what this is going to give us. That would be 1 plus 0 plus 9 plus 2. That's 12, is it? Let's check. Oops. Now in the exam, it will be very rigorously checked. It won't have these kinds of mistakes in the actual question. There we go. We hope. Min row sum. Ugh. Okay. Was that the answer? Okay, good. Now, the types of things people do wrong in this sort of question are maybe that they do this at the top. So like something like this. And they don't do it for each row. And then they start getting weird answers, right? The same as if you're totaling things in a two-dimensional array for each row. Okay. So how difficult do people think this is? Is this harder or easier than that linked list question? The duplicate linked list. I think this one's easier, but I don't know. Yep. Question?
I have a question. If we make like small bugs like these in our questions, like do a 0, 0 instead of a
Oh, yep. And I've actually copied it back wrong. Yep.
how would we pass this hurdle, or like how many points would we score? Like
Okay.
if we were to make tiny little bugs in our code.
So this is a really good question. What happens if we make tiny mistakes? So if you made a tiny mistake, if you really just did this and everything else was correct, yeah, you probably would pass the hurdle. You probably would if it's just one mistake. And the thing is, if you made this one mistake, maybe none of the auto tests pass, right? And you might get a pretty good mark and pass the hurdle. There are other cases where you might, let's do an extreme example. Sometimes people look at the auto tests and think, well, the most common answer is 1, so I'm just going to write this code, and that means I've passed 3 out of 10 auto tests. That means I'm going to get 3 marks. No, you'll get 0 marks. Honestly, people do this. And actually, in some cases, if we've got something like that's returning 1 or 0, like, you know how sometimes we have functions that return 1 or 0, this could pass 50% of the auto tests. And then people will say, no, well, I pass, because no. We go and look at it all, code like this will get 0 marks. It doesn't matter. We can all fluke passing a couple of auto tests just by doing something like this. Or maybe even the equivalent, maybe you've written 10 lines of code, but by chance it always returns 1, but it's not, the code you've written is not related to actually solving the question. You can still pass a few. Now, people usually know if they've done something like this, but sometimes when it's returning 0 or 1, just be wary if you're passing about 50% of the tests, right? If you're passing, say, 9 out of 10 tests, it's probably a small bug. But if you're only returning either 0 or 1 and you're passing 50% of the tests, just be aware, all right? But yeah, we will actually go through and look at all your code. So a small bug like that, but I can't give you like an exact case for every kind of bug you might have though. Okay, but we want to see that you've solved the question, that you can work with a 2D array, or you can, you know, work with a linked list or something like that. That's what we're looking for. All right, the other thing is, if you do have bugs, don't just randomly change things, right? You know, just before when I had that random bit of pasted code in the wrong place, if I just started changing randomly some of my things and changed it to less than or equals, or, you know, stuff like that, you can suddenly break all your code and make it worse. So don't panic and randomly change things. All right, it's time to have like a quick 5-minute break. And then we're going to have our guest speaker, Tom, who's here. We'll set up with him. So have a break and come back, and we'll get to hear Tom talking about arrays and other sorts of cool things too. We're going to do more hurdles tomorrow. Let me know what you want to focus on though.
Oh yeah, for the email that you.
Oh, hang on.
Yeah.
Yeah, I'll talk to you in a minute. I'll just...
How's it going?
Hey, how are you?
Good to see you again. It's been what, like 3 years? All right, good to go? Lovely. Hello, everyone. So my name is Tom. I used to work for 1511 for many, many years. It feels wonderful being back here. I now work for a company called Optiver. I'll talk a little bit about what we do, but I mainly have two reasons for being here. The first one is to talk a little bit about some of the lessons that hopefully you've learned throughout your course and kind of put them in the context of what we actually need when we're in industry. And the second one is to look through an example problem that is hopefully useful arrays exam prep. That's the plan. We'll see how we go. So very briefly, I have to scroll through these slides. Let me see if I can get that working. Oop. Can I scroll through my slides? Uh-oh. Technical difficulties. This is terrifying. My screen appears to have frozen up. This may take another moment to resolve because I'm going to need to leave out of this share and re-enter it. So we'll try this. This is the first thing you learn in industry, is that live demos never go to plan and that you always have to be a little bit prepared for that. All right, 1 second. I'm just going to get back into VLab, back into here. Ooh. Ready. Let's see how quickly we can get this going again.
They all know about being disconnected.
We may need to. Let me try this first, and if it doesn't work, then we can. We're good? Oh, alrighty. Magical. Let me just open up all my things again. Please, Firefox? No? Lovely. I'll talk briefly while I'm trying to open things up about a little bit about Optiver. Maybe I'll introduce myself first. So at Optiver, I work in our research platform team, which means my job is building systems that our researchers and traders can use to figure out things about what's going on in the markets. And in order to explain what's going on in the markets, I should probably explain a little bit about what Optiver actually does, which I can do once I open this set of slides. Maybe, if we're lucky. Oh, no, we're not lucky. Open with Chromium. Let's try that. Chromium. Open. Maybe that's going to work. Yay, alrighty. So what does Optiver actually do? Our job is basically being in the financial markets all the time, across the world, and being ready to buy and sell stuff. So we sit there, and if someone wants to come along and buy something, we'll sell it to them. And vice versa, if someone wants to sell something, we'll buy it. Through doing that, it basically means that you don't have to wait around for somebody else who wants to buy or sell the same thing. And it basically improves the ability of the financial markets to do things and for people to get what they need. In order to do that, though, we need a lot of technology. The financial markets are a place where there's lots of different people trying to achieve different outcomes. And so speed is an important part of what we do. We end up building quite complicated technology systems using languages like C that you've been learning for the last 10 weeks to make decisions on like a nanosecond level. So performance is really important. Building like stable software that doesn't segfault, as some of you may have seen. Null dereferences are a problem with us as well. We try and avoid them, but that is a problem we have to deal with as well. And why am I actually here? So Optiver works with UNSW. We sponsor a couple of different prizes for courses. But as part of that, we also wanted to come in and give you a bit of a taste of what it's like to be in the industry. Ultimately, we are looking for more people who can help us solve these interesting, hard problems. We run a variety of programs for people in first and second year as well to kind of get a taste of what it's like in industry. And I'll link to some of those at the end. I've already spoken about myself, so I'm going to move on from that. The theme of this first part of the talk is to talk about what did you learn this term that will be most valuable after uni? And I want to get your thoughts. What have you learned this term that you think is going to be valuable after you leave uni? Any suggestions? Yeah. Pointers. Excellent answer. Yes. So pointers are absolutely something that's going to be valuable after university. I'll talk about that but more in a second. Other thoughts? Yeah. Determination. Yes. So trying to get through a hard problem, absolutely. What else? Yes?
Just complex problem solving.
Complex problem solving. It turns out that the next slide is called problem solving, as you might be able to see. So well done on that one. And you as well, yeah? Patience, absolutely. So these are actually all things that I'm going to talk about now. So thank you. Yes, indeed. The first one that I want to talk about a bit is problem solving. I would argue that coding is probably the closest that humanity has come to raw problem solving. A lot of other things are problem solving as well, but they are, you have to build a system. You have to build a physical thing to be able to solve the problem. maybe maths is an exception as well. But I would say coding is pretty close, right? I need to start with something, get into something else, and I need to describe the process to do that. That's what coding is. Now, in 1511, you've seen lots of problems. I'd wager it's probably more than 100 problems that you have solved over the last 10 weeks, which is really impressive. Now, the problems you're going to have to solve are going to continue getting harder. Unfortunately, 1511 is not all there is, and there are more problems which you're going to get to solve. But the techniques that you have learned in this course to be able to solve those problems will stay the same. Asking good questions. It's kind of obvious, but if you are able to formulate your question correctly, you can ask the tutor a good question. That's half the way to solving the problem. Some of you may have heard of rubber duckies before. Is that a thing you've heard of? Who's heard of a rubber ducky? Okay, a couple people. So there's this concept of you get a rubber ducky, like the one you have in the bath. You show it your code. You explain your problems to the rubber ducky. And you say, rubber ducky, why is my code not working? And it turns out that even just phrasing those questions in that way is a way to be able to solve the problem. So being able to ask those good questions, super important. Another one, breaking problems down. This is an important thing. If you try to solve some massive thing like we need to provide the best prices to the market, that's a crazy big problem that no one person can solve. But if you can break it down into smaller and smaller pieces until you end up with little programs that you write to get little bits of the way, that's going to get you to solving the big problem as well. And so as you go through your uni career and then afterwards as well, breaking those problems down is super important. The last one, someone said perseverance. I can't agree more. Just getting to the point where you're looking at a problem and saying, I have been looking at this for a week and I cannot figure it out. Your two choices there are like quit, resign, and like go start up a farm or something. Or your other choice is you can actually just say, I'm going to keep going. I'm going to figure out this is a system I can solve, and you solve the problem. So those are all important skills. The other thing which I wanted to point out here is that we've been learning those skills in the concepts of programs, right? We've been programming. But what's actually secretly happening, and maybe Angela hasn't told you this, is we're reprogramming your mind. Now that you have taken 1511, you're going to see the world differently because you can see a lot of problems in terms of I have some input state, I need to get to some output state, how am I going to get there? That's like an engineering sort of philosophy or like a science philosophy that will apply even to like interpersonal problems. You know, if you're leading a team maybe and you've got problems with who's doing what or different people disagree, you can approach that as a programming problem effectively. And that's a really useful way to look at the world. So that's problem solving. That's the first thing. Oop. Second thing, C coding. Someone mentioned pointers, and that's like an integral part of C, right? And you might ask yourself, like, why should we learn C first? Some of you who may have programmed before, or if you've heard about other courses at university, might know that C is not the easiest language to learn. It has pointers. As you know, pointers are not easy. It's also arguably not the most useful language, right? Like, we don't generally write, big websites in C. We don't generally write user applications in C, generally. So why should we teach you this? Should we say, no, Angela, I want to learn Python instead? I would argue no. There's two reasons why. The first one is by learning C, you've got a really good picture of how a computer actually works. You can picture the ones and zeros moving around, how the types are represented, the fact that there's memory and pointers within that memory. That picture of the world is going to serve you really, really well because it means that when you encounter a problem, you're not just trying to figure out, why is Python broken, but you can see the layer below. You can understand why Python might be doing something or why your website might not be working in a certain way. You get this deeper view into the system, and particularly at Optiver, where what we're doing is these really, really fast systems, these really performant systems, or where we're working on these really big problems, it's very useful to have a detailed picture of what the computer actually looks like. So if you've been sitting here sort of thinking to yourself, there must be an easier way, why am I learning all this pointer stuff? Linked lists are hard, I get seg faults, this is annoying. That's why. You're understanding how a computer really works. The other thing is that you get very fine-grained control. In C, you know exactly how many bytes your particular variable is going to take up. You know pretty close to exactly what your CPU is doing. Whereas in other languages, you don't get that picture of the world. And having that fine-grained control is really important. Again, especially at Optiver, where we're thinking about things in terms of nanoseconds, trying to optimize everything, needing that control is important. But even outside of that, having that control is just a really useful way of getting the most out of your system. Third thing, understanding requirements. So all of you have now done, or almost done, 2 assignments. I had a little look through them. They look like fun. I hope you're enjoying them. As part of that, you had to read the spec. Now, that sounds like an easy thing when you're getting started. Oh yeah, I'm just going to go through and read the text and it'll all work out. But actually going through and understanding the little nuances, understanding where it says that you need to have the system operate in a certain way, doing that fully and understanding that problem is not easy. Similarly, in future courses, you're going to have specs where it's probably even more unclear, where you've got to ask questions, where you've got to try and figure out like, oh, how is this supposed to work? When you get to industry, you're probably not even going to have a spec at all. You might get a JIRA ticket that says, hey, we need to fix this problem. One line. That's not a specification. That's just a starting point. And so having the skills to be able to sort of dig into that, ask questions, to try and refine your understanding, prototype, see, oh, this doesn't pass the auto test, maybe I should do something else. Those skills are super important. The style guide as well is something where I can see why people would say like, oh, this style guide's annoying, right? Like I have to pass 1511 style, why are there marks for this? But it turns out that in industry, that is an important thing. Your code needs to look the same as your colleagues' code. You need to be thinking about the problems in the same way as your colleagues. Because if you go to one part of the code base and it looks completely different to another part, it's a real pain to understand what's going on. The last thing is, in industry, you are going to have your code reviewed. Now here, that review happens via your tutors, who are all diligently sitting there looking at your assignment and leaving comments, leaving feedback. In industry, it'll be by your peers, maybe by your manager, maybe just by somebody else in your team. They're going to be looking at your code, they'll be asking you questions. They'll say, hey, why did you write it this way? Why did you do that thing? And so being in a mindset of, I know my code's going to get looked at, and how am I going to make sure that it's sensible, that I've designed it in a reasonable way, that it's easy to follow? Those are all like really good questions that you've hopefully started to learn here. That's a skill you'll keep building. The final one I left out, or I want to mention, is adult life. Now we're in the third term here. Raise your hand if this is your first term at UNSW. Okay, so like a reasonable chunk of people. I would say that like there's a lot of skills that come with being at university that you don't quite get when you're in high school. Things like time management. Who here has finished assignment 2? Not that many people, right? Maybe that's because you've got a whole bunch of other assignments. You're trying to manage all these different things that are going on at the same time, right? And so being able to manage those sequences of things is really, really important, and it's a useful skill. Learning new things as well. This is new to a lot of you, I would imagine. A lot of you have not programmed before. So that's a really important skill as well. When you're in industry, you're going to be expected to pick up new things quickly. Working with others, I would say particularly helping other people. For any of you who've been sitting in the tute and someone else next to you has had a problem and you've like sort of leaned over and helped them, or you're having a conversation being like, oh, how does this work? Those are super valuable skills that are going to serve you well in industry. And the last one is this like freedom to manage multiple things at once, which I mentioned a second ago. It's hard having 5 different things on at the same time. Different priorities, different things you've got to do. So those are all skills that hopefully you can take out of this course and that will serve you well in the industry. I'm going to put this up for a second because we do have some information here about like early career programs, things for first and second years which you might be interested in. They're programs which I've helped be involved in running and I would really recommend them. So that's a link and I'll put it up again later. What I want to do now is to walk through a question that comes up at Optiver. It's a problem we've really had to solve. I'm going to show you sort of the core part of the problem because it turns out that in reality there's lots of different pieces. But like I mentioned with that problem-solving attitude of breaking things up, this is a core piece that if you can understand this, it's one way to solve this bigger problem. So at Optiver, how does it work? How do we trade? At the top, that diagram there, we call it like an exchange. That's got a whole bunch of different people who are putting up buy and sell orders. They're saying, I'm willing to buy something. Somebody else says, I'm willing to sell it. The exchange is sort of the middleman who's matching people and saying, oh, you want to buy that, you want to sell the same thing. Okay, you trade. We have a connection to the exchange and we can get information from the exchange that says things like, oh, the price of this is $3. We can also send messages to the exchange and say things like, we would like to buy that thing for $4, let's say. So one thing that we need to do in this case is we need to keep track of what we've sent to and from the exchange. We don't want to just send messages off and forget about them. We'd like to have a record. Particularly, I mentioned earlier, I work with our researchers. It's really important from our researchers' perspective to have a clear record of everything we've ever done because it helps them understand maybe we made a mistake, maybe we could improve something. So that process of listening to the messages between the exchange and Optiver and recording them separately is super, super valuable to us and very important for our research. Now, can anyone point out what might be a problem with the diagram as shown here? What's something we might need to add to this system? Any thoughts? Is there any way in which this system could go wrong? Yes? Labels, okay, yep. So I probably haven't done the best job. It's a very minimal diagram. That's a fair point. Is there some way in which the system could go wrong? Any thoughts? So I only have one line going between me and the exchange. Is everyone happy with that? Sound good? No? What's the problem with that? Yeah, you could lose connection, exactly. Alternatively, we might also just get a really slow line. Maybe the exchange has made some mistake or something, it's not configured correctly. That line might be super, super slow, and so we're going to hear about things really late. So what we actually do in practice, we have multiple lines to the exchange. We can hear about things from multiple different places. It means that in case something goes wrong, we can still hear about it. It means that we can sort of listen on multiple fronts. We have redundancy. But that means that we're going to need to have multiple different recordings because each of those connections has its own messages going across. Making sense so far? Any questions about that? Cool. So at the end of the day, we end up with a bunch of messages getting sent over our different connections that look like this. Connection 1 gets order 1, 2, and 3. It gets them at certain times. Connection 2 gets them at slightly different times. That might be because the system on the exchange's side does things in a certain way. It could literally be that the cables are different lengths. When we're talking about stuff that we deal with at Optiver, cables not being the correct length and light speed playing a role in how quickly we get messages is something we have to think about. So in those two first connections, you can see that we've got order 1, order 2, and order 3, but at slightly different times. Additionally, connection 3 doesn't even have order number 3. And this is something that can happen as well, where we drop a packet, is what we call it. This is where something goes wrong in the system, maybe the exchange, something goes wrong on their side, maybe it goes wrong on our side. We just didn't hear about order 3 from connection 3. Now, in all those cases, what we really want is to be able to do two things. The first one is to get this sort of raw feed. So at the end of the day, I'd like to be able to go through one file and say, what was the complete history of every message that I ever got from the exchange on that day? And we want it to be time ordered because it's very helpful for us to be able to sort of replay it in time. This is what that looks like. Any questions about that? Can anyone suggest another thing that might be useful for us to do with this data? What else might I want to do to it? Yep. Sorry? Back it up? Absolutely. We definitely need to back it up. My team deals with that a lot, 100%. So we're going to want to have multiple copies of this. Is there any way in which we might also want to process this data, though? Something we can get out of this data to sort of summarize it a little bit. Any thoughts? Yeah? Organize it. How would you organize it?
I don't know.
No, fair enough. That's okay. That's a good idea. Yeah?
Group it together by some attributes or
Absolutely. So grouping. Grouping is a good idea. There's two attributes here. Probably time doesn't make a lot of sense to group it by, but order seems reasonable. I would actually say, though, from our perspective, the thing that really matters to us is the first time we hear about a message. So let's say I'm sitting here and I've got 3 different feeds telling me stuff. Really, the thing I need to know is like, what was the first time that I heard that message? Because if I hear it for the 3rd time, hopefully I'm already processing that message. Hopefully I've already reacted to it. So in this case, what we want to do is summarize down to this sort of processed view that tells us time 1, time 7, time 17. Here's the first time you heard about these messages. So what I'm going to do now is I'm going to jump into VS Code and we're going to code something up that can actually solve this problem. Code. Alrighty. We may only have time to do the first part, and I'll leave the second part as an exercise to all of you. We'll see. So I've got some code in here which defines what a packet looks like. It's got a timestamp, an order ID, and then some extra information about maybe what's going on. I have this print packet function, which lets me actually print out what's in that packet, so I can sort of see it on the screen. And then I've got this reconstruct function. And what I'm going to do with this is I'm going to take 2 different streams. I know we had 3 before, but let's just do 2 to get started with. 2 different streams, and I just want to join them together so that it looks a lot like this. So, any thoughts? What am I going to need to do here? How would I join together these two different feeds of packets? I'm just going to print them out. How would I get started? What tools do we think we're going to need to use here? We're going to need some if statements. What else are we going to need? Yep, for loop, absolutely. We're definitely going to need a for loop. I might actually use a while loop here, if that's okay. Everyone's comfortable with while loops, I'm hoping. Anything else that we're going to need? I'm going to say we're probably going to want to keep track of where we are in this feed of packets, right? For each of these feeds, we want to know what index we're at. That seem reasonable? Let's start with that. We're going to say we've got feed 1 pos, as in the position in feed 1. We're going to start at 0, and then we're also going to start at 0 in feed 2. Sounding reasonable so far? So what do I want to do here? Any thoughts? What am I trying to do now? Yep.
Make a for loop iterate
Eat through each what, sorry?
position until you reach the length.
Absolutely. Sounds great. Now, your first attempt here might be something like, okay, I'm going to go through for, I'll do a while loop here. While feed 1 pos is less than feed 1 length, and we'll do something inside of here, and maybe we're supposed to say feed 1 pos plus equals 1 at the end. That seems like a good start. Ideally, though, I want to print these out in timestamp order, kind of like we had here. So am I able to just go through feed 1 and then go through feed 2? Who says, yes, I can do that? Who says, no, I can't? Who's not sure? Okay, some people aren't sure. So if I went through all of the first feed, I'd miss out on checking what was going on in that second feed here. So by looking at this example, I'd be going through connection 1, and then I'd be going through connection 2. Ideally, what I really want to do is I want to go through both of them at the same time, and I want to keep track of what comes next. So let's go back here. Rather than saying while feed 1 pos is less than feed 1 length, I'm going to say while feed 1 pos is less than feed 1 length, and, oh, that was very loud, feed 2 pos is less than feed 2 length. And so now what I'm doing is I'm keeping track of both where I am in the first connection and the second connection at the same time. People feeling comfortable with that? Now that I'm inside of here, what do I want to do? What should I do next? Presumably my goal is that I want to print something out here, right? We have this print packet function, so I'm going to want to say print packet of something. What should I do? Any suggestions? Someone here? Yep.
What is at the correct position?
Correct. Okay. Print what is at the correct position. What do you mean by correct position?
Current position.
Oh, current position. Absolutely. So we've actually got 2 current positions. Which one should I print?
One that comes first. So feed 1.
Yep. Okay. So the one that comes first. What do we mean by first here? Do you just mean like we're going to print feed 1, feed 2, feed 1, feed 2?
No, like print all of feed 1 and then all of feed 2, or maybe compare which one came first.
Okay, so we're going to compare which one came first. That's a great idea. What we want to say is, I'm looking at 2 packets. Let's say I'm looking at order 1 here and order 1 here. Which one of those came first? I'm going to print the one that came first. So how could I check which one came first? Well, if we look at this struct here, this packet struct, it's got a couple different things in here. One of the things it's got is this timestamp field. So that's what time we saw that packet. So we think we could use that maybe to tell which one came first. Yeah. So how could I write my if statement to figure out which came first between the packet in feed 1 and the packet in feed 2? Compare the timestamps. Okay, so I'm going to say something like if, and now we've got to do a bit of typing here, feed 1 pos is, let's say it's less than feed 2 pos, then in this case, oh, I've missed something here, feed 1 timestamp, because we care specifically about the timestamp here. if the timestamp of the position in feed 1 is less than that in feed 2, that means the packet in feed 1 came first. And so we want to print that packet. Seem reasonable? So I'm going to say something like print packet, and then feed 1, pos. So this is going to print out that packet, and we can see it on our screen. What do I need to do after this? Am I done? Increment the position, absolutely. So feed 1 pos plus equals 1. So now that we've printed out that packet, we want to jump to the next packet. Is that it? Are we done now? What else do I need? Yeah, we need an else statement. Now, I'm going to be specific here, and I'm going to do an else if, just because it will make our lives a bit easier. The condition that we're looking for is something like if feed 1, let me see if I can, there we go. Paste, there we go. So the condition I'm looking for now is if this is greater than or equal to, that covers off the other case. What should I do here? Print, yep, so we print the second one. Print packet, feed to pos, and I also need to remember to increment feed to pos here. So let's walk through what we're doing. We're saying, okay, let's just take the first one and the second one. Let's say we're looking at connection 1 and connection 2. Well, we compare the time. The time of feed of this connection 1 was earlier than connection 2. That means we're going to get into this if statement branch. We're going to print out that packet so that you can see, okay, feed 1 has this particular information. And then we're going to increment this by 1. And now we're looking at order 2 in connection 1 and order 1 in connection 2. So the next time we go through this while loop, we're going to compare the two again. And actually, this one is greater than this one. So we're going to print out the packet from feed 2. We're going to add to feed 2. And now we're comparing this order to this order. So which order are we going to print out now? Yep, so we're going to print out order 2 from which connection? From connection 2. Exactly, perfect. And so we can go through here and you can sort of follow on what's going to happen. There's an interesting case here, which is where the times are the same. Have we handled that case correctly, do we think? Yeah, why is it going to work? Because we said greater than or equal to. Cool. Can anyone see any problems with this code? Yep.
I feel like we should be incrementing both in both cases.
Incrementing both in both cases.
Well, I feel like you end up comparing like the old one to the next one.
Yep. So that's a great point. So the point there was that we're comparing the old one to the new one. Now, in this case, what I'm trying to do first is just to get to this view here, this raw view, where everything's in the same. So I'm going to end up with duplicates. I agree with you that if we were trying to do that second sort of processed version, then we might want to look at doing something like that. Absolutely right. But for the moment, let's stick to this one, just because it's sort of a sort of first step, breaking down that problem a bit. Anything else that's missing? I'm going to go ahead and compile the code while we're waiting, just to make sure. So DCC. Oh, I've done something wrong. Line 42. What's wrong on line 42? Thank you. Yep, semicolon. Everyone can shout it out. Again, problem with live demos is sometimes things go wrong. Use of undeclared identifier on line 52. So this one doesn't actually make sense. I added that in earlier, but we're going to increment them separately. Let's try clear, and then we'll do it again. Cool. Let's run. So everyone's happy this is going to work? Let's try it. Prints out some stuff, and then seems like it all works. Okay. So that all looks like it's working fine, but there is a bug in here. I'll give you that much. Does anyone want to guess where the bug might be? It's right here. Yeah, absolutely right. Exactly. Yeah, it's right here. So we've gotten really lucky here. Let's try and change the timestamp. So here's the example data that I've got. I'm going to set it up so that now we get a really big delay. So the last 3 packets in that second feed of packets is going to be much slower. They're going to come in a lot later. Let's see what happens then. Hopefully, I can trigger this error. Oh, seems to be working. What have I done wrong here? The thing that I'm concerned about here, I'll spoil it to you all, is that feed 1 pos is going to get incremented. And what's going to happen is at some point we're going to be reading past the end of our array because feed 1 pos is equal to the length of feed 1 while we're still doing comparisons against that second part. Now, I've not been able to trigger the error here, which I'm a bit surprised by. Not sure what's gone wrong. But to be super safe, what we're going to do is we're going to say if feed 1 pos is less than feed 1 length and the rest of it, and the same here I'm going to do down here, feed 2 pos is less than feed 2 length. And this is going to make sure that I never accidentally go off the end of my array. I think we've gotten lucky here in that it didn't show the error, but there is an error there. And the trouble is, oh, yep.
I think it's because you've done double and instead of double like or.
Oh, interesting. Let's take a look at it.
Because it's only showing the up to the like the final feed pos 1.
Excellent pointing out. You've spotted the bug that I actually couldn't see. So if we look at our test case here, I was finally saying, oh, this is all good. This is fine. But if we look through it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I've only got 17 packets here. I'm not printing out all the packets. And so, as you say, what's happening is that those last couple of packets are getting dropped off the end. Let's go back to the code I had before and fix that bug. Excellent spotting, thank you. This is why peer review in your code is very important, because having a lecture full of people to tell you when you've messed something up is very useful. They'll point out when things go wrong. So let's try again. Whoa, now we've got an error. Interesting. So what's the error actually saying here? Stack buffer overflow, access past the end of a local variable. And if we read at the values, it's telling me that feed 1 length is 10, feed 10 pos is 10, and so we're accessing past the end of an array. Ooh. So, I kind of spoiled it already. Thank you very much because you spotted that bug for me very nicely. If I go ahead and do feed 1 pos, feed 1 pos is less than feed 1 length, and I'll do the same thing here. Let's try it again now. Oh, still didn't work. Why didn't that work? Feed 1 pos is less than feed 1 length. Let's try and debug it. We're going to have to debug this in real time, so I'll appreciate all of your help. So let me just first of all save and make sure that I've compiled the code. Very important step when you're debugging under pressure in an exam. Just make sure. Okay, we're still running into it. Alrighty. So now this error is happening on the else if line. Oh, interesting. So this doesn't even work, right? Now, why doesn't this work? This doesn't work because we're trying to check feed 2 length, but actually feed 1 here, we're still checking it. Ooh, interesting. Now we're all in a position where I'm not sure what to do either. So what are we going to do here? Maybe we've got to rethink our approach a little bit. Let's try something slightly different. What we're going to do, we're going to get rid of this check. We're going to try something else. Now we knew before that when we had the code that was working, it was working and only printing up to 17. What were you going to say, sorry?
Is it necessary to have that second condition?
The second condition, what do you mean?
Because it's just like, it's literally just the else.
It's the else. Yeah, so the reason why I put that in there was because I was worried about what happened if we had the incorrect positioning. So you're saying we could try putting in feed1 pos less than feed1 length here, and then put the else in?
Yeah. Oh, and then else if like it's less than.
Okay. We can definitely try that. What I'm going to try though is a little sort of Hail Mary pass that you guys can also try in the exam. Let's pretend that I planned all of this and it's already was supposed to be what was happening. So we knew before that it was working and printing up to 17, right? Let's try this. Oh, when we had the and here. So, there we go. If I compile now, this does work, but it's missing out some packets. So what could we do now to solve this problem? What should I do? I could keep trying to play around with that if statement there, which admittedly, like we probably could get it to work, but there's a bit of time pressure. I'm in the exam. I'm not sure what to do now. Let's try something out. What can we do? Yep.
You could add another while loop to just print out the remaining packets from the second connection.
Great idea. So what we're going to say is something like, while, so I guess I should say first at this point, we know that there is only one feed that still has packets in it, right? Because otherwise we'd still be in that earlier while loop. We can tell that either there's some packets left in feed 1 or there's some packets left in feed 2. So what I can write is something like, while feed 1 pos is less than feed 1 length, and then we can print the packet out. Feed 1 pos, feed 1 pos plus equals 1. We've got this. What's going to happen if we're at the end of feed 1 with this while loop? If feed 1 pos is equal to feed 1 length, what's going to happen? Nothing. It's going to get skipped, right? We can do the same thing again for feed 2. Let's try that. Feed 2 and feed 2 pos. Let's try this. Why not? I misspelled. Oh, thank you. You had me really worried. You said that's not going to work. I was like, oh my goodness, I've broken something really big. But as I said, having a room full of people who can tell you when you've misspelled things is very useful. So thank you, everyone. What's happened here? Now we're at the end. While feed 2 pos is less than feed 2 length. What have I done here? How have I messed this up? So we print it out all the way to the end, and then feed 1 length is 10, feed 1 pos is 10, feed 2 length is 100. Ooh, how did that happen? Ah, okay, that we can fix. That's just wrong. Don't know why that was there. Let's try that now. All right, hopefully, buzzer beater. The invigilator's just telling you, oh my goodness, the exam's about to finish. We've got all 20 packets now. Whew, alrighty. That was stressful. That was more stressful than I intended it to be. But that's an example of the sort of problem that we had to solve at Optiver. That's also an example, admittedly under extra time pressure, of the ways you might approach solving it. Some of the things you saw me do there included, we got to a solution, I thought it was going to work. Oh, it doesn't actually work. Okay, let's try and figure out why. Well, I had a partly working solution before. Let me try a different approach to get to the end. Now, all those are things that hopefully you'll be able to do in your exam and when you go into real life. In real life, hopefully you would also have more time and you wouldn't be as sort of under time pressure and 200 people in front of you looking at you. But I think this hopefully demonstrates some useful things. I'll finish off by just putting that the slide back up so that you can scan this if you didn't already. I'll be around after the lecture if you've got questions. Thank you very much, everyone. I don't know if you wanted to add anything.
Thank you very much.
Thank you. Thanks. Whew.